focused primarily on biodiesel exhaust emissions, in particular on what are called mobile source air toxics. So when you combust fuel, you get all sorts of things coming out of the engine. There's carbon dioxide, you hear about that a lot. Carbon monoxide, you might hear about nitrogen oxides. But there are a lot of other things that aren't, they're not considered criteria pollutants, so people don't necessarily know about them as much. So some of these include what are called mobile source air toxics. So these include things like formaldehyde, acetaldehyde. A lot of them are carcinogenic, and ones that aren't just do really bad things to your respiratory system. They attack your nervous system. There's all sorts of really adverse health effects. But they're present in much lower concentrations in fuel, which is why they're in exhaust. So they're not often studied as much. So this study used what's called Fourier transform infrared spectroscopy to measure the exhaust emissions coming out of a tailpipe. And what we focused on was what the effect of using biodiesel as a mixture with diesel, how that would affect your exhaust relative to like normal diesel, just petroleum diesel. So the data was collected using an engine that was running on a drive cycle that looks something like this. You have a transient cycle, which modeled driving through downtown Burlington. And then there were 3 steady state cycles, so just steady state phases where the engine was just at a constant load, constant electricity. And as you can see, what's kind of cool about infrared spectroscopy is you can take these measurements every second as the engine is running. And so you can see there's a direct correlation between what's going on with the engine and what's coming out of the tailpipe. So this was a pretty cool observation. And then, so looking at this graph in particular, you can see each of these colors represents a different biodiesel blend. So the blue one is what's called B0. There's 0 biodiesel. It's just pure petroleum diesel. And then red is 10%, 20%, 50%, 100% biodiesel. So as you can see from this graph, formaldehyde is one of the mobile source air toxics. It's the one that was detected above detection limit in our study. And with increasing biodiesel fuel content, there was a decrease in formaldehyde. So that was good. So that means, like, at least in terms of toxicity relative to formaldehyde, at least it was less toxic with increasing biodiesel. Other things that we looked at were the effect of engine load on the emissions. So with formaldehyde, it's produced as a product of incomplete combustion. So if you look over here, diesel is what's known as a straight chain alkane. So it starts out over here in terms of oxidation state. And biodiesel looks almost the same as diesel, but it has this little oxygenated pair at the end. So what happens with there's a lot of disagreement in the literature about whether or not biodiesel should produce more or less of these mobile source air toxics. A lot of mobile source air toxics are carbonyls. So on the scale of like oxidated state or compounds, this is what petroleum diesel looks like, this is what biodiesel looks like, and that is what a mobile source air toxic looks like. So some people say, well, we've observed an increase in these carbonyl emissions and mobile source air toxic emissions. And we think it's because biodiesel has oxygen in its structure, so it's going to produce things with more oxygen. But then other people look at it and they observe a decrease in the mobile source air toxics, and they think it's because, well, biodiesel is at a higher oxidation state than diesel. So under the same operating conditions, under the same combustion conditions, you're more likely to achieve more complete combustion. So with complete combustion, you'll get carbon dioxide, and you'll get fewer of these products of incomplete combustion, including mobile source air toxics. So it's kind of cool to see in our study, well, we had a decrease in mobile source air toxics with increasing biodiesel fuel. And then also the consistency with increasing load causing a decrease in the mobile source air toxic production, but an increase in CO2, which again makes sense because you have more complete combustion and you're burning more fuel. So that is the general gist of my